Our next presenter, we kindly ask that if you have any questions during his presentation to use this QR code and write them into Slido. Also, at the end, there'll be another QR code where you can give your feedback to your presenter. In addition, there'll be an additional QR code where we would highly appreciate any feedback on this first day of this conference, because we're going to look it over, and if we can make tomorrow a better day, then we will from your suggestions, and we will certainly take those suggestions and make an even better conference for next year. Okay. Our presenter is a happy developer building stuff on and off the job. He is the author of MX Rocks and Parents of the Dead Screencast, an avid open source contributor and functional programmer enthusiast. Please give a CraftHub welcome to Magnar Sveen. Magnar, welcome.
Thank
I
you.
always ask, that's my thing for this conference, to ask everybody that this is CraftHub's 10th birthday. And we have grown and grown and grown. And we're witnessing the IT world is exploding and growing faster and moving and moving and moving, and it's moving at, I think, almost hypersonic speeds now. Quick question for you. What advice would you give to a young professional programmer, let it be a programmer or a sister engineer, that's entering this field now to help them along on their career? Thank you.
Yeah, that's a good question. I think first of all, I'm happy that I'm not in that situation. There's so much to learn right now. I don't know that there's a solution, the right solution for everyone, but the thing that worked for me at least was to have a hobby project. I created a game 25 years ago, and I'm still working on that. And that forced me to do all of the stuff, like create a web page and create the backend and integrate with the database and put it in production. You had to do all of it. And I think even if you're not going to be a full stack developer straight away, you really need to know how things work and giving you the basic idea of how everything fits together. So that would be my advice. Get a good hobby project. So thank you all for coming. I'm very happy that each and every one of you came. My name is Magnar Sveen. Excellent pronunciation over there. And yeah, Emacs Rocks is a screencast about how this old weird editor is pretty cool. And I also created Parents of the Dead, which is a live pair programming, test-driven, creating a game from scratch. But Datomic. Who here has heard about Datomic prior to this conference? Almost everyone. So the other of you are hearing about it for the first time right now? Cool. Datomic is the thing that you would draw like this on an architecture diagram. In other words, it's the replacement for the trusty old SQL databases that we all grew up with. Oftentimes, a new database will place itself in a supplementary position, like a time series database or a key value store for your session data and things like that. But Datomic places it pretty squarely as the database. In other words, it's where you would keep your crucial business information. So Datomic is written in Clojure, which is a functional data-centric language on the JVM. And it was created by this guy, Rich Hickey, who actually created both Datomic, the database, and Clojure, the language. And now you can use Datomic with any language, but there is little doubt that Datomic and Clojure are best buds. They go very well together, almost like they had sprung from the same mind or something. So, what kinds of databases are there? Well, lots, but most prominent is the classic square relational table database. Then there's the more modern, maybe, NoSQL document database. And there's the simple key value store. And Datomic are none of these. I recommend you to also drink. Yes, it's hot. Okay. Datomic's model is most similar to semantic triples, which is a term coined by the semantic web movement in the resource description framework. And this sounds very fancy, but it really is not. It's almost like grammar: subject, predicate, and object. Sarah reads a book. Or in Datomic, we call it entity attribute value. And Datomic stores its data in this format. So there's the first of 11 lessons that Datomic is on some fundamental level different from the databases that we grew up with. So let's take a look at entity attribute value. Sarah reads the book 1984. This is a piece of information. Here are some more. John reads The Beach. 1984 was written by Orwell, and The Beach was written by Garland. And Datomic is a database of facts like these. Let's break it down, and you can see more precisely what it models. So Sarah reads 1984. We now have the entity attribute value. 17 is the entity ID, and it has an attribute, a person with a given name, and that value is Sarah. We have the book title, which the book is another entity, it's number 23, and that has an attribute title 1984. And then we connect these together, where we say that 17, the entity, the person who reads 23, the book. Makes sense somehow? Okay, let's just add a few more for example. We're adding a new person, another entity 40 is George Orwell, and we'll add to the book that it has an author, which is pointing to George. So yeah, these are the entities, entity IDs, mind you. These are the attributes, and these are the values. And when you look at this, you might notice a couple of things. First of all, you might notice that these are references to other entities. And the significance of that we will talk about very soon. But first, you might have noticed that these look a lot like the names of tables. Like there's a person table and a book table. And in that case, this would be the columns, given name and the title and so on. So let's explore that a little bit. What does that look like? So for Sarah and the person table, it would look like this. She has an ID, she has a given name, no family name that we know of, and she reads 23, which is a foreign key to another table, and here that is. Here's the book. So this looks familiar if you've worked with SQL databases. Of course, you have to... Oh, yeah, there's George, because the author is 40, right? And you have to add these nulls in, because, well, tables, they have a slot for everything, so you have to fill it with something, which adds these nulls. But if you notice, in the original here, there's no need to create sort of space for information that we do not have. But okay, instead of looking at this data in a table, what if you look at it like nodes in a graph? So we have entity 17, which is Sarah, entity 23, which is the book, and entity 40, which is George. And then these attributes that point at other attributes, they become sort of the edges or the vertices of the graph. And to illustrate to you how this actually works when you're working with Datomic, we're going to write a little bit of Clojure code. Don't be afraid, it will be okay. Has anyone written Clojure before? Oh wow, that's why you're here. I see, thank you. Okay, so we will define person to be the entity in the database with the ID of 17. And now we can look up the person's given name, and it's Sarah. So this is no surprise. But what happens when I'm looking up what that person is currently reading? Do I get the number 23 back? No. I actually do get that other entity. It is an entity in the database that has the ID 23, and I get it straight back, and I can read from it, that I can look up the title, for instance. So now I'm followed the graph over to the book, and I can continue. I can look up the book's author and that person's family name, and I will get Orwell. So now I've followed the graph, which is something you would expect from a graph database. Now, there's another cool little trick that I'm going to show you, and that is, what if we start at the author? Because the author doesn't currently have any entities that's pointing at something else. But you can, in fact, follow the arrow the other way. So this is the book's author, but there's a sneaky underscore there. And that sneaky underscore means follow this reference back. So the thing that happens here is that we're actually looking up from the author all of the books that is pointing at it as the author. Now we get a list of all the books, and we can look up the book title from the first one, and we're back to 1984. So this works very much like a graph database, I think. I'm going to add one more example, just so you can see sort of the thing that is with these attributes. Because Sarah is a person, but she's also a user in the system. She has an email. And I'm pretty sure that George Orwell does not have an email. On the other hand, George is an author and he has a biography and he's born in India and so on. So we are able now to model the world closer to what we see it as. Datomic can model square data and sparse data and graphs and mixed data like this. So we can take in the complexities of the world into our model. And you might notice, if you have ever struggled with sort of having the perfect domain model in your code, and it doesn't quite fit into the relational square tables, this is known as the object relational impedance mismatch. This doesn't have that problem. Okay, Datomic. I said that Datomic is a database of facts, which begs the question, what are facts? We're going to start very simple with Sarah. Is Sarah a fact? No. I think we can all agree. Is Sarah reads a fact? Well, it is a complete sentence, but I would argue that it is not a fact yet. Is Sarah reads 1984 a fact? Now we have all of our E and A's and V's in line there. But no, it is still not a fact. So let me ask you a question. What happens if Sarah instead starts reading The Beach today? Does the fact that she did read 1984 yesterday change? No, it does not. Because what's missing here is time. when did Sarah read 1984? And this never changes. Now Sarah is free to start reading The Beach. And maybe 10 years ago, she was reading The Hobbit. So adding time to the equation here removes the need to update our data, because the past never changes. So we only add new facts. So Datomic is a database of facts that never change. Okay, story time. I think it was 12 or 13 years ago, I saw David Heinemeier Hansen typing in TextMate, and it was so amazing that I wanted to learn everything. So I started learning Ruby and Rails, and that was very freeing. Coming from Java, it was excellent. And one of the things that I learned from the Ruby on Rails community was to always add created at and updated at to my database tables. And it was great. I felt like a professional IT developer, because when I looked at my data, there was always these two columns there telling me when it was created, when it was last touched. It was perfection. And I even learned this incantation from MySQL, where MySQL would do all the heavy lifting for me. It would set the default timestamp and update that. It was amazing. So let's take a look at our table again, and we will add in these columns. And let's take a little look at this data, because we notice that created at and updated at are not the same. The idea is probably some auto-increment counter, so that's obviously from the created at time. And I'm betting that Sarah didn't change her name, and we don't know the family name, so it's probably the book, 1984, which has the identity of 23. It's probably the book that she started reading yesterday, right? Probably? Okay, so today she started reading The Beach instead, which is number 77. So now, okay, tomorrow, maybe Sarah is entering our preference pane and actually adds her family name. So what can we really tell? Well, we know the user was created at a certain point, but what does this updated at tell us about the data that we are looking at? Not very much. And what happened to 1984? Is it gone? Let's take a look at the same thing with facts instead. So we know that Sarah has her given name, and she's reading book 23 yesterday, and we will add 77 for today. And tomorrow, we will add the family name. And not only is no information lost, but we're also keeping track of time for all our attributes and their values. Pretty cool. I'm sure you have some questions, but we will take those at the end. Okay, let's write a little query. Here are the 3 facts. Sarah reading The Beach. And this is very concrete. Like there's a concrete Sarah. We will replace that with a variable name. And the question mark in front indicates to Datomic that this is a placeholder. And the 17 is the concrete idea of one specific entity, and we will replace that with P. And here's an important part, right? Because both of the old ones was 17, and the same thing holds now. The P is the same, so the person with the given name is the same person as the one that's reading the book, B. And the title is title. And now we have something that's, instead of being about Sarah and 1984, about concrete data, it instead expresses the relationship between these attributes. So to turn this into a query, we can add find the title where this holds. Of course, we have to send some parameters in. We're going to send in the database and the name. And this is Datalog. It's actually a query language that was created in the 70s, but Datomic has sort of embraced it. So to run this query, I pass it to the function queue, and I send in the database, and I send in Sarah, and I get the beach back, which is cool. Sarah is currently reading the beach. But there is something going on here, right? If you remember, Sarah was also, will have all of these facts in the database, right? There's the Hobbit, there's 1984. We didn't throw those away. So what's going on? You see, the database that we're sending in here, it is actually a materialized view into the current state of the database, into the current state of all its entities and attributes that are still active in a way. And in our model, in the model that's here, you can only read one book at a time, which I would suggest is a good idea, but my wife does not agree. So in this case, it will only give us the last one, the latest one. But we didn't throw that data away, right? So we can ask for the same query, but pass in the database as of some other instant in time, like yesterday. And now we get back 1984 because that's the book that she was reading yesterday. And we can pass in the day before that. And the latest information we had about Sarah's reading habits at that point was that she was reading The Hobbit 10 years ago. It's not that big a book, but that's the latest we have. And you can even pass in 10 years in the past, before she started reading The Hobbit, and get an empty result back. And if that's not enough, you can even say, just give me the history of the world, at least the history of this database, give me everything, and there they all are. Hobbit, 1984, and the beach. So Datomic keeps historic data for all your attributes and entities. And I have created some SQL tables with history in them before, and that works in a way, but this is for all of them, all your values, all your attributes. Okay. I want to zoom out a little bit from like looking at both just the thing that Sarah's reading to something that illustrates the entirety of the database in a way. So let me tell you a little story. At a former job, we were asked to create a new report for the higher-ups in the business. And it was quite a bit of work because they wanted a fancy report. But when we were done, we could sort of call this function here, generate report, and it would spit out this beautiful report with graphs and everything. And the business was happy with that, but they did not anticipate that we could also do this. We could generate the report for last month, and we can generate the report for the month before that, and the month before that. And in fact, we ended up giving them 2 years of reports because we didn't have to change any of the code that generated the report. We just passed in a database snapshot of that given point in time. It's pretty cool. You can query the database as it was at any point. And all of your code just works with it, right? Okay, in order to understand how this is even possible, I have one point before that. I will allow you to guess, wager a guess. When we were running these reports, which were quite involved and took some time, lots of heavy queries, do you think we used a data warehouse, a data lake, or we just ran it straight in production? It's a trick question, right? Of course, we ran it straight in production. But that sounds a bit crazy, because what about all the heavy queries? Didn't we just grind production to a halt? And that's why we have to learn a little bit about Datomic's operational model. Not much, mind you. I know it's late and everyone's warm and tired, but just a little bit. I will start us off with a quote. Design is to take things apart in such a way that they can be put back together. And it's this guy who said it. It was Rich Hickey, the creator of Datomic. And he loves taking things apart and putting them back together. For instance, the database. The classic database server is responsible for at least these three things: transactions, queries, and storage. But not in Datomic. They are split apart. Of course, the server still has to do the transactions. Otherwise, you're in the Wild West. We do want the ACID qualities of the database. And that is what the server is doing. It's transacting things in such a big way that, in fact, we do not even call it the server in Datomic. We call it the transactor, because these other responsibilities have been moved. So who does the queries? Well, the clients do. The clients will actually read straight from storage. So we call the clients peers because they are not clients of a server. They're peers in the life cycle and the beauty of the database. And when I say that the storage is external, it's actually pluggable storage. You can use DynamoDB, you can use Cassandra, you can use any SQL database. Of course, when the client wants to write something, it will send it to the transactor, which in turn sends it to the storage. But reads bypass the transactor entirely. And at one point, I remember, actually, I didn't notice that the transactor was down because all of the reads were still working, and it was just when I tried to update something that nothing happened. But how is this possible? It's possible due to immutability. It's possible due to that facts never change. And it's possible because you're always looking at snapshots. So the client can cache everything. You can fetch all of the history that it needs. I'm not going to go into how Datomic does it, mainly because I don't know, but also because everyone's tired. Yeah, okay. So clients really are peers, and that's why you can linearly scale your reads and just spin up a server to create more reports if you want. Queries never disrupt other services. Remember this? It's where we find the books that Sarah is reading. I just want to show you a cool little thing that I noticed just the other day, actually. What happens when you instead find the name and pass in the title? And we get Sarah and John back. Sarah and John are the people in the database who are currently reading The Beach. But did you notice what we changed? Well, we flipped the title name around, and now in the old one we found the title and looked for the name, and in the new one we were finding the name and looking for the title. But this part doesn't change at all. It's almost timeless, because it expresses the relationship between these attributes in a way that is not dependent on the question that we're asking. I find that pretty cool. Datalog, surprisingly expressive. You're pretty familiar with these right now. It's entity, attribute, value, and time, right? Well, I have been lying to you. The T isn't time, it's transaction. So let's look at 3 facts. With sound effects as well. These 3 facts were asserted at the same time. They belong to the same transaction. And this tells us something important, right? These facts are related. There's no longer just facts flying willy-nilly in the database and nothing keeps them together. They're kept together by the transaction. And in Datomic, transaction is just another entity. and that entity has the time. So if you want to know the time, you can look it up on the entity there, on the transaction there. But then you can add more stuff to the transaction, like who did it and why. So it's basically like event sourcing. But imagine using a database where you can ask, why did this happen? I'm sure all of you, at least I have, looked at some code and thought, what moron did this? And then you did the git blame game, and it was turned out to be you yourself 6 months ago. Yeah, imagine doing the same thing with your data. Pretty cool. Now we can be the moron on multiple levels. Okay, so here's the history query. You remember, it's the one that gives us the Hobbit 1984 on the beach. Sort of lacking. It should include some more information. It should include the time when she was reading those books. So we will query it now. It's a title, there's an instant, and if you remember, P person reads B, that's EAV, and the last one is transaction. And the transaction is an entity that has its own attribute, transaction instant, and we query for it, and voila! Here we have times that she was reading all of these, at least the times that they were asserted into the database. So the T in EAVT isn't time, it's transaction. That gives you some cool stuff. Now, we are closing in on the end, but there is one thing that is totally missing so far from this talk. I'm not sure if any of you have an idea what it could be, but I will say that a database without data in it isn't very useful. So let's just take a little look at how we would add data to Datomic. So here's the fact. It's the family name. And if we want to add that into the database, we will ask the transactor to do that with this instruction, database add EAV. And you can do more at a time, so we wrap it in another list. And then we call the transact function and pass in the connection to the transactor. Yeah, this is the most the tiniest little piece that you can work with. You add a new fact. And of course, you can also retract something that is no longer true. Mind you, this does not remove anything from the history. It only adds a retraction to the database. But these are the simplest building blocks. But you don't have to work on such a low level normally. Let's say we want to assert some facts about Sarah and her reading. We can pass in a map, giving both the given name, the family name, and the book that she's reading at the same time. And this would add 3 new facts to the database. But that book reference there, 40, that doesn't mean very much. If you've been following along, you know that 40 is in fact George Orwell. I have an error in my slides. But so let's replace it with something that would work, book title 984. And this the transactor would now find the book titled 1984 and point the reference to it. This, of course, requires that book titles are unique in our system. But if the book wasn't in the database already, we could add it in the same transaction. And we would use the magical string, the book. The string itself doesn't matter, but you see in the next map there's a database ID of the book, which is just a placeholder for an actual ID that the Datomic transactor would help us with when we created a new entity there, just so we can point the person to the book in the same transaction. So let's try adding some of those metadata things that we talked about. It would be, this is an actual magical string. Datomic TX means any attributes that I add to this map, please add it to the actual transaction entity. So we could maybe add some source that this came from our website, maybe the event is that there's a user registration. You can add whatever you want. So expressing transactions in Datomic, you just use regular old data. You don't have to concatenate strings together or anything like that. Okay. There's one more. And it starts like this. What storage do we as developers give ourselves for our code? It's Git, right? Everyone's using Git for their codes nowadays. I used to use SVN, and before that I used CSV, and before that I just used a folder on the drive somewhere. But what does Git give us? It gives us the full history of everything. Imagine going back to that folder. Maybe it's on a shared network drive. Maybe it's on an FTP server somewhere. I remember having folders named by their dates, and then copying yeah. That's not a great way to work. The way it should be is like the Git, right? You can see the history of everything that's changed. The code used to work last week. Okay, let's go back and see what it was last week. That's great. This is the way it should be. That's number 11. Let's treat our users' data with the same care as we do our code. Because available storage space has increased 1 millionfold since the classic SQL databases were created. So we can and should have better tools for ourselves and our users. And that was the 11 insights after 11 years. And here they all are. Thank you.
Magnar, thank you for, you left me in the dust, but thank you for, thank you for an insightful presentation. Before we close this, if you have any questions, I think we're only a few, so if you have any questions, ask them directly to Magnar.
And if you want, you can also stop me afterwards. That's
Okay.
also okay.